Good evening, everyone. Hello and welcome to today's live stream. We've got a special class live stream for you today, and we're going to mix up a little bit differently from what we normally would do, where we go through how to create a system or create a certain thing inside of Unreal. Instead, we're going to talk a bit more generically, and that is how to get good at using Unreal Engine or any real software. Really, it's the same logic we're going to go through here is going to apply mostly to other software too. So this will be useful for absolutely everyone. Now, the reason why I'm doing this is because I often get asked, like, how do I get started when I'm coming up with a solution to a problem? We'll do like a question time on our Wednesday live streams, and people ask me a question, and I'll figure it out live in front of them and put something together. People will ask me, like, how the hell do you know where to begin? Well, we're going to try and demystify that today and talk a bit more about how can you learn Unreal Engine properly and not have to rely on videos that I put out or anyone else puts out. It's kind of a weird counterintuitive thought that I want to teach you how to not use my videos, which is odd, but it hopefully be quite useful for everyone here watching us live. So hello everyone, hello everyone in chat. So we've got some new faces, old faces, and familiar names there. We've got hello there, Little John. I'm doing well, very well, thank you. Deirdre, Cell Shock, hi Lottie, hello Great Soul, hello Jasper, sorry. Hi Eric, hi Paul, hello Flame, Darwin. How are we all doing tonight? Hope everyone's doing well, okay. Now there will be a chance to ask questions, so we'll definitely go through questions and asking like about more specifics about how to learn Unreal. But first of all, let's go through some of the core basics of Unreal. Again, any software really, and talk more a bit about like how my brain works. Okay, now a lot of this we're going to go through. I do a lot internalization, so when I'm coming up with a new system or coming up with a solution to something, I'll think about a lot of this stuff in my head. But it might be useful as you're learning these things to plot them out on paper, plot them out on Word, Photoshop, whatever you want to use to help you get your ideas down on paper. It really does help. And I mean, it really does help. I have a book here that I have with a pen, and I use this to do little doodles for calculations and charts and diagrams to help me understand certain things. So I really do recommend having like a book by your computer with a pen, so you can just jot out little diagrams, little equations, things like that. It helps a lot. And so I have this here. I have another one on this side too, but it's the one I use now. So yeah, that's the first tip. Make sure you do have a book next to you so you can put stuff together. It also works quite well to have it as like a to-do list. So when you're coming up with ideas for things you need to do, you just write it down. You can cross it off as you go. But more on that another time. So let's go forward into like how we learn Unreal Engine. So let's jump across into this. Okay, so Unreal Engine is a very complex piece of software. It has loads of tools, loads of features, loads of nodes, has loads of blueprints, as tons and tons of stuff. So whenever I'm coming across a new tool or new node or a new a part of the engine that I'm not familiar with, internally I'm going to ask myself these four questions. Okay, I'm going to ask myself what it is, how do I use it, why would I use it, and when should I use it. These four questions will help me understand what the hell I'm looking at. And it's very important you do so. And if you're following a tutorial of mine or someone else's, when you're going through that tutorial, ask yourself, do I understand what it is? Do I understand how it works? Do I understand why I need to use it? And do I understand when I should use it? If you don't answer all those questions, then I'd recommend you stop whatever you're doing and figure that out. And we'll go through that figuring out process in a moment. But you do want to figure that stuff out. Don't just rely on the videos or guides or documentation and just trust blindly that's going to give you the right answer. It's only by understanding exactly these four components that we understand when and where we should use certain things. So So this is all internalized when I'm going through things. So, for example, last week I was looking through. I was doing more animation graph stuff. So I was messing around with animation graphs, looking at what more features there are in there. Because I know I was only like skimming the surface, or like maybe not skimming the surface, but I knew there was more there than I actually interact with. So I started looking into it and experimenting with it. And I would ask myself at each one of these little nodes or tools or bits of code and say what it is. How would I use it? Why should I use it? And when should we use it? And we'll come back to these 4 questions later when we go through an example of how we come across building something in Unreal from scratch. So next, you ask yourself, okay, the thing we need to actually really learn is the core communication. Like, how do we communicate from one blueprint to another blueprint? So we need to understand that core communication. That's your core fundamental thing that you need to learn and understand. And we'll go through this when we go through a working example in a moment. We're going to go through and do like a basic skill system example in a moment, and apply all our learning here to it. But we need to understand how they communicate. And you may be familiar with the little blue pins that you find when you drag them in and promote them to variables, and when you cast into them, you get your little blue pin. That is a reference. That is a pointer reference. If you're coming from a coding background and you see C++, that's a pointer. And it points to a location in memory. So it points to a specific instance of an object that's in the world. If you've got a reference to that, then you have access to its variables, functions, anything that that thing has, you have access to, as long as it's not private. So you can access all that stuff there and then communicate through that. So a lot of the time, the puzzling part of working with the blueprints is not working out what you need to do, but it's more about how can I connect the dots from object A to object B. Yeah. So let's go for example. I want to get a hold of the item that my player's holding in the child actor component they have. Well, I can get the player character node and get player character, and that will return the character the player has. I then can get a component by class and find the child actor component that is attached to that actor. That child actor component itself will spawn in the child actor it's been assigned, and will have a reference to it. So I can get child actor reference from that. And so from these 3 nodes, I can get an exact reference to the thing I'm holding. So we'll go through a working example again in a moment so you can see that in action. But we have to understand that communication first. And we are going to go through also how to know which functions, which variables, which things you can find on each of those references momentarily as well. So let's go across and look at how we plan for a new project. So let's say I've got given a new thing to solve, a new task, a new mechanic to implement. Where do I begin? Where the hell do we begin on this grand journey into Unreal Engine? Well, we have to do 4 things. We have to first of all define the problem. So you're given a mechanic, and that mechanic will have a definition of what it is. And hopefully, if you've got a team of people around you, this will be from a game design document usually. Unless it's just yourself, then first of all, be sure about yourself and write it down what the problem actually is. Don't make it up as you go along. It's really bad to do so because you can't plan for anything that you need to put in there later. It makes you have to go back and redo a lot of the work you just did. So make sure you do define what the problem is. Secondly, once you've got that problem defined, you need to break it down into its constituent parts. Okay. So I used to do an exercise with my programming students where I would get them to write down the functional list of operations to create a cup of tea. And they'd have to be as specific as possible. Give me variables that they would have, and it's just pseudo coding how to make a cup of tea. And that is the idea. We kind of break down the tasks, break down the steps involved. Much like we approach anything inside of our day-to-day life, we have to break problems down. And just like any other career too, a chef, for example, will break down the cooking process into steps, and that's what we see in recipes. Okay, so we break the problem down into what we need to build together. We then thirdly need to identify the information that is needed. These will be our variables. So now we know what the hell we actually need to work with, what variables we need, what information does our system need, what information does our player need. These will all be our variables. And then finally, we've got to identify what it needs to do, and these will be our functions. Now, when I'm thinking of a new system or trying to think of a solution to something, I'll ask these 4 questions and break it down. And you'll see me do this live on stream quite a lot of the time. You'll see me do it on question times. You'll see me do it on live streams on Saturdays. And you'll see me like talk through what the problem is, what I need to do with the problem, identify and talk about what variables I need, and also talk about what I need it to actually do. And we'll go and we'll go through that live in front of you, and you'll see that process going there. So what does that actually look like? So first of all, let's talk about a skill system. So first of all, we define the problem. The skill system needs to allow the player to unlock skills and upgrade certain skills once they have been acquired. Some skills will need to have prerequisite skills already learnt before it can to be learned. And some skills will also be locked if a sibling skill is chosen. So there's our problem. That's our mechanic. That's the game design documents brief. Okay? Although simplified, but there it is. So we have to break it down. So the skills need to be stored and recorded with its rank. Okay? Where it's been upgraded to. We need to know that it's a fireball spell and we've got it to rank 5. We need to know that it's an ice storm and we've got it to rank 2. We need to know those 2 pairings. They are tangentially linked. Okay? They need to be there. The skills, though, need to have unique information about them to be able to read not just information about this skill itself, but also if there's any prerequisites or sibling skills. So we need some sort of repository of skill information, such as name, description, thumbnails, maximum rank, and prerequisites and sibling skills. So we need some sort of way to read information about that from something, somewhere, somehow. And finally, we need a bit of UI to be able to read both these pieces of information to show not only all the skills available, but also the ones already attained. So we need to know a combination of what skills are all available and which ones we have and which ones we don't have. We need that sort of differentiation there. So let's talk through how this could be broken down into its information. So when we identify the information, we're going to identify 2 things. So let's take just our skill system, not looking at UI, not looking at the individual skills and their components, looking at just the skill system. If we're making a skill system like a skill component system or like a skill tree component, things like that. So the skills are attained with ranks. So we need to have that marriage there. We've got the skill and the rank, as I said. And a good way of managing a marriage like that is what we call key value pairing, which is a map. So with any kind of list of things, you've got 2 options. You've got array or map. Maps are useful when you've got a pairing that you need to link the 2 together and the keys are unique. For example, you can't have 2 fireball skills. You can only have 1 with a certain amount of ranks. Okay. And also use an array if you're using like an ordered list. Okay. So if you need it to be in a specific order every single time, you use an array instead. And our skill system also needs to have the upgrade points. Okay, this would be like a simple integer, which tells us how many points we have to spend. Simple as that. Then we go on to the functions. So what does it need to actually do? Well, we need to be able to learn the skill. We need to be able to upgrade a skill. We need to be able to query a skill and unlearn a skill. So I've been asked like what some of these mean, especially queries. Queries are a super useful way of building a function that can simply just return whether you have something or not. If you think about how you query like an Excel spreadsheet or a database, you're just searching for a condition, a filter, and it's saying, yep, you got some, no, you haven't. Simple as that. That's what that is. And we're thinking that, well, we need to learn a skill, definitely. We need to be able to click a button and learn it. Unlearn a skill, maybe you have to reassign our skills or refund them. So we've got loads of little things like that. Upgrade skill, we've already mentioned that when we learn a skill, we can also upgrade it to a different rank. And query skill is going to be useful for us when we do queries to determine what we have and what we don't have. Okay. Now, I'm not saying these are the only 4 functions you have, or they're the only 2 variables you have, but these are where you start. You have these, and then you have these. And as you're building these up, you may see opportunities where you may insert more functions or more variables as you go. And a lot of these functions will also have their own variables assigned to them. So again, I apply the same logic that I just did to break this down into the functions itself. So for example, in learn skill, I need the skill ID that I want to learn. Yeah, I'm going to need to know what skill I want to learn. That's it. Yeah. And when I think, okay, well, when I'm learning that skill, I need to be able to query that skill, whether I have it or not already. Do I have the upgrade points? You've got various things like that you need to do checks in for. before you actually award the skill. So it's the same process we repeat for functions. We break them down and talk a bit about where those variables and functions fit. So let's talk a bit about how to get better at Unreal. We're going to go through that example in a moment and how to do that in Unreal itself, but how to get better in Unreal in general. Okay, so you need to first of all practice. I use Unreal Engine every single day. Okay, I don't know everything about Unreal Engine. No one knows everything about Unreal Engine. I know a lot, but definitely not everything. So the only way I can learn more and know more is by practicing with it. And what that can lead to, and what it often does lead to, is experimentation. You need to be experimenting with the different nodes, different systems, and understanding what they do. So let's say, for example, I get a node that I've never used before, and I don't know what it does exactly. The documentation is a bit poor on it. I'm like, I have no idea what this does. Even Matthew Wadstein hasn't done a video on it. Yeah. So we'll go through what this node actually does. So what do? Well, if it's got values in it, what I do is I chuck loads of values up. I'll go, well, let's put an extreme value in like 10,000 or a million or something and see what happens. Try breaking it. It's much like if you want to learn how a car works, you take it apart and look inside it. It's much like that. We just give it some extreme values, extreme things into it, put in some print strings and work out, okay, if it's taking in this value, outputting this value, what's really going on there? And I'll study that node. I'll study what the hell it's doing and try and work out what it's doing. And like, what happens if I put in a player character into it? What happens when I put a non-player character into it? Yeah, and from that learning, I can deduce what the hell it actually does. So by experimenting, we can actually understand what things do. It's the third point, understanding. As I mentioned at the start of this stream, when you're following these tutorial guides or following any of my videos, try not to go too far ahead. If you come across a node that you just don't know what it does and the video hasn't explained what it does, spend some time trying to understand it. And I wish in every video I could go through every single node as I go to explain every step along the way. But eventually I'm going to repeat myself like 10,000 times because we use a lot of the same nodes. So some get missed. But try to stop and understand what the hell's going on. If you don't know and truly don't understand what the hell that node's doing, ask, look around, Google. Yeah, see what research you can find to help that builder understanding. Learn how the rules of the game works. And it's by doing these three things is where you put yourself into becoming better at Unreal Engine. Yeah, this is how you get good at Unreal Engine. So let's take a look into Unreal Engine itself and talk more about what specifically Unreal has that help you get by. And also talk about this skill system and how we can actually implement something like this from scratch in Unreal. So let's jump over to Unreal. And I'm in this new project here. So first thing I want to do is create a skill system. Okay. So let's go ahead and create a little folder and put that in here. Now I'm not going to do a full skill system tutorial in this one live stream. That'll be for another day or another series. Whatever. Okay. But we need some sort of skill tree system to demo this. So I want my skill set tree to be a component of my character. It doesn't have to be a component of my character. I could do it directly straight onto the character. I can open up my third player character and just go through that if I wanted to. I could do that, or I could do a component. Now, the reason why I do it as a component is partly just because it keeps it compartmentalized. It's a little bit easier to manage. If I've got multiple player characters or multiple things that have skills like enemies, for example, I can easily give them those skills. But honestly, it doesn't really matter. You could do it either way. I just like it in a little component itself because it's a little bit tidier, easier to manage, and it kind of follows a lot of what Unreal Setup is already. Unreal Setup is a lot of the actors, their functionality is because of their components. Yeah, we have collision because of a component, we have a mesh because of a component, we have all these things because of components. So it's just following that motion onwards. Yeah, we just carry on doing that component. So I'm seeing some questions in chat. So let's take a look at what people are asking. To learn C++. If you're trying to do the same in C++, it's exactly the same process. Okay. If I go back to it's exactly the same. Yeah. If I want to, if I'm doing C++ version of something, I still ask myself the question, how, what, why, how, and when. And I'm also breaking it down exactly the same way. Like, what's the problem? What do I need? What variables do I need? And this is where you build your header file out of. Yeah, this is how you define your header file, and you use that to start building your source file. So it's a great way of doing that. Now, if you're trying to learn more of the fundamentals of C++, then I'd suggest you just go ahead and learn C++ in general and not Unreal Engine. Yeah, go just learn C++ in general, how it works, how coding works in it, some of the core functionalities of work. Yes, it can be slow, can be a bit daunting, but do break it down a bit, okay? But it's exactly the same situation, yeah? You still want to experiment with things, like, got a new function, let's try out the new function. When I say node, it's just another word for function. So what you're seeing here, if I'm doing a node in my component, just think that's a function, yeah? So you put in that function in, you'll know what it does, chuck in some extreme values. It's exactly the same, no difference at all. So let's go through Great Soul. We're going to go through that in a second, I think. We'll explain that in a second, I think, definitely. So let's take a look at an actor component, okay? So create an actor component, and we'll call this one skill tree system, okay? And we open this up. Okay, so now we're getting started. And this is where we said we defined the problem, broke it down, identified the variables, and identified the functions we need. So let's put all those in. So when I'm getting started here, I'm going to put the blanks of those in. So functions, I'm going to need learn skill. And next one we'll do unlearn skill. Upgrade skill. Query skill. Okay, so they're the 4 basic ones I came up with earlier. And as I said, there's no doubt going to be more later, but these are definitely the 4 I need, 100%. So let's go into the variables of this. Okay, so variables, we had the skill matched with its rank and the upgrade integer. Okay. If you want to learn, it's exactly the same in C++. It's just more visual and easier to follow. Yeah. In my header file, I'm going in and creating a learn skill, unlearn skill, upgrade skill, query skill, and I'm making the variables. Okay, doing exactly the same thing in there. Okay, doing this is like writing a header file. Exactly the same. So in this variable here, we're going to put in our skill. Oh, I don't know if I renamed it. Skill ranks. So in this skill ranks, as I said, I'm going to use a map. And I'm going to map this to something, okay? I don't know what yet. Let's make it a string to start off with. And I want to make it definitely a map. And I know definitely the value is going to be an integer. Rank 1, rank 2, rank 3, rank 4, so on. So, yeah, simple as that. But this key, we're probably going to change at some point. Okay, so we're going to use string for now, because string is quite flexible. We'll leave it there. But we'll come back to that in a moment. The other one I need to know is how many upgrade points I have. So I have to go to variables, make upgrade points. And we'll turn that into just an integer. A single integer. Okay. Now, this is the breakdown we did. Okay, this is the breakdown we did in that little example I told you. And this is something, again, I would internalize. So I'm just going through in my head, like, what are these main skills I need? What are the main functions I need? What are the main variables I need? So I know this is the minimum I need this to be successful. Yeah. Everything after this is going to be useful. So let's go through and start setting some of these up. So let's start off with how we would represent our skills first. Now, with the skills, I mentioned we need some sort of way to store data about individual skills. There are numerous ways of doing this. One, we could make skills individual classes with their class default set to different variables. 2, we could do a data table with a list of all the skills and all the details in the columns. And 3, we can do data assets, which are separate assets which contain the information about each skill, which is sort of like the class way of doing it, but a lot cheaper and a lot easier to manage. So let's talk a bit about then data assets, because that's what I'm going to use here. And it's up to you which one you use. Like the main difference you're looking at data assets versus data tables. Do your research like I did my research. I looked into what is a data, what are the limits, why would they introduce data assets, and then look at what data assets give you. They're both read-only sources of information, but with data assets we can apply functions to them. They are easier to access. They're a bit easier to manage. Yeah, so you've got a few things you can take advantage of there. So let's go ahead and create a data asset. Now we go, and the way I'm learning how I do things like this, like how to create a data asset, I got from just documentation. I was going to Unreal Engine's documentation, type in data asset, follow what it did. I'm like, cool, I know how to make a data asset now, which I then translate into a video for you guys. So you don't have to read. So in the parent class here, we're going to pick in here primary data asset. And some people will say, like, how do you remember this stuff? Go back to what I said about practicing. I use it every day. Yeah. And trust me, there are many things that I forget all the time. I even have to watch my own videos back sometimes to remind myself how I do things, because I just forgot. And it does happen. But I've been using I've been using data assets quite a lot recently, so I know how to do them. So we're going to call this one skill data asset. And we'll go in there and we'll define our skills variables. And again, I would have done a breakdown exactly the same. What are the variables and functions I'll need on my data asset? It's mostly variables. So we need a name. We'll do as a text file. Again, if you want to know the difference between name, string, and text, check out documentation. That's what I do. Hover over these, they'll tell you exactly what they do. Yeah. So a string is a text string. Most common thing you'll find is a text string. Okay. Text, as you see, is a localizable text string. So if you've got text that you want to be localized into different languages, use text. And if a name referring to the name of another asset inside the engine or editor. So we use a text thing for our name here. So if we were to localize it to like Spanish or German or Russian, whatever, we can do. So name, description. Oh, thumbnail, which is a texture. So search for texture, 2D. And there we go. Max ranks, I guess. Max ranks we'll have as a integer. And then we're going to put in our prerequisites, because we mentioned before we need to have prerequisites and and sibling skills. So if I go to my variables here, I'm going to go in here one called prerequisites. In other words, these are skills I must have before I can learn this one. Prerequisites. And this is going to be an array of other skills. So if I just click on this little down arrow here and search for skill. Oh. Skill data asset. And make this an array. Because it's a list. It's a list of different skills. Okay. I can have 1, 2, 3, whatever. Prerequisites available there. Other variables we may need in here is also siblings. So these are ones that are going to lock this if any of these exist in our system. So this is where we go through this. And this will do for now. The beauty about data assets is I can always go back in and add more in if I want to later on. But that's the core minimum that I need. So I'm going to close that now. So let's talk about how we get started with these different functions. Okay, so where do we get started? Well, first of all, skill ranks. We're not using a string anymore. Let's change that to the data asset. So I'm going to do skill data asset. There we go. And let's go to learn skill. So learn skill. What do I need to know? I need to know the skill I want to learn. Simple as that. So I've got to learn skill. We go to inputs. I'm going to add in a skill data asset as its parameter. And this will be skill or skill to learn. Yeah, we'll do skill to learn. Okay. And with learn skill, I could easily just go into get skill ranks and just do add to the map. Like this. And add 1 to that. Okay, that's the simplest thing I could do. However, when we're doing anything like we're adding to a variable like an array or a map or anything really, usually you want to do some checks or conditions before that happens. So are there any conditions for learning skills? Well, let's break it down again. What's the process? What's the problem? So identify the problem. We need to learn a skill. Now I need to assign a skill to my skill ranks. Break it down. Okay, when we're learning a skill, we have to check to see whether the skill is already learned or not, whether it can be still upgraded instead of being learnt. Is it going to be do we have siblings locking it off? We've got these things that we've just in our design document have identified as things that we need to consider. So let's put these considerations into our function. So break it down, move these guys along, and first of all check to see, can I actually learn the skill? Do I have the skill already in my skill ranks? So simplest way of doing that is doing skill ranks, find, and putting that here. Now, you may be wondering, like, well, how do you know about the find node? Easy. We just drag this out here, and if I don't know what the hell I want, I just type in map. That's what I'm dealing with here. And I'll get the category for map. And there are all the things related to maps. I would literally just sit here, read each tooltip, until I find one that sounds like what I want to do. Find is the one in this case. Finds a value associated with the provided key. So, yeah, do that. Or I can use contains. I can do that. Does the same thing, but you'll see that find here gives me a boolean and a integer, and again, if I hover my mouse over it, it tells me what it's outputting. So here I'm outputting the value associated with the key, default constructed if key was not found, and the true is if true if an item was found. False indicates nothing in the map uses the provided key, whereas contains just does this. It just doesn't give you the integer, so it's kind of like pointless. So find does a job for us. So let's put that in here and put that into learn skill, and we're going to do true. Now a lot of this is the same as what we want to do with our query skill, so why don't we just do that? We should. Let's just take this, cut that there, and go into query skill, and we build this one up. So I'm just going to put that in here. I need to know what skill I want to query. Yeah. And I want to return these two values. I want to return this, and I want to return this. Okay. And I'll just rename this one to be rank. And return value is skill learned. Do we have it? Okay. And I can easily make this one also pure. Pure is a coding computer science thing that is just transferred over to Blueprints, and basically it means, and again you can Google search this pure, what are pure functions, what are impure functions, and it's the gist of it is that you only use pure if you want something that is not going to change any data. It's mostly just getting data, reading data. It's not changing anything, and you want to get live right then what's the most recent data of that. So query skill pure makes sense. So now I can go back to my learn skill and drag out query skill into there. I can now put that into my branch like that, and then I can go into my add if it's true. But what if it's false? What if I don't have it? Sorry, it goes to false. Sorry. If I don't have it, it will add it to my map. But what if I do have it? What do I want it to actually do? What happens when I click on a skill that I already have learnt? Well, I want to be able to upgrade the skill. Cool. I'll just drag upgrade skill out as a function and put it into true. But we come across the same problem that we had to define earlier. Define the problem with the upgrade skill. We want to be able to upgrade skills only if we have the skill available to us. Like the ranks available to it. So we'll go into functions, and we'll create a new function, can upgrade skill. And this is going to ask what skill we can do. So just drag out a new skill. And we'll just drag out the skill itself. We're going to get the maximum ranks. And I want to find it in my skill ranks. Find. Or, better yet, I can use my query. Yeah. I put the key in that. That gives me my rank. I can just drag that out and say if the rank I've got is less than the maximum ranks, I'm going to output a return node, which is this Boolean. Ooh. Breaking it down into the problem and solving it bit by bit. What's the information I need? Do I have that information already at hand? Can I use it? Or do I have to create a new one? In this case, I needed to check whether I can upgrade a skill. So I had to devise a new way to understand that. Okay, I didn't have an implementation for that. I know where the information is, but I didn't have any way of fetching it yet. So that's when I made this function. Okay, so it's another function in there. And again, this one is perfect case for a pure function. So I'll make it a pure function because we're not changing anything. So let's go back to our learn skill and go into upgrade skill. Now, this can upgrade skill can go in before or you can go into the upgrade skill. I'm going to put it into the upgrade skill. It can go either. It doesn't matter. You can go either. But I feel like it'd be better in the actual function itself because I'm only going to really check whether I can upgrade something at this moment in time in here. So I'm only going to look for upgrading skills if I can actually upgrade it. So we need a skill. So we're going to add that as our input for the upgrade skill. We get a Boolean in here. And the upgrade skill, we return true or false, which is where our branch comes in. And if it's true, we're going to increase our skill. Okay, and that's going to be taking our skill ranks, finding the value, or we can just do query skill. That's the same thing. And this query skill can tell us, okay, get the rank plus 1. And then we want to set it back to our skill ranks. So get skill, add, and we're going to add that value back onto it, onto true, and we need a skill. And with a function, I can either drag the line from the skill here parameter to here, a bit messy. So what I prefer to do is just drag out and search for it here. That is exactly the same as dragging the line from here to there. Okay. And I learned that through experimentation. Okay, so there we go. Got a now upgrade skill going through this, and like that. However, we have a thing here where we can actually make this actually quite valuable to us because we've got a branch happening here where it's true or false, meaning there's a chance this function could end without actually upgrading the skill. So it may be beneficial, and we may not ever use it, but it could be beneficial to add a return node and return whether or not it was successful in upgrading the skill. Success. So on false, it was not successful. If it's true, we'll tick it and make it successful. In this one, I'm not going to make it pure because we are changing something. So I'm going to leave it like that. So I'm going to go back to my learn skill. And now you can see we've now got our parameters on here, skill and success. So the skill here, again, skill to learn, just drag from here, skill to learn. Okay, great, we've got that. But what about the prerequisites? What about the siblings? Well, those go into our can upgrade skill, yeah, or even learn skill even. So let's do one of can learn skill. So again, much like we've done for the can upgrade skill, we're doing a can learn skill. So we're going to go into our skill ranks. We need to know the skill we want to check. So we're going to go in here, skill data. Let's name it skill, like that. And with the skill, I can then check it, those prerequisites and the children. So let's first of all focus on the prerequisites. I need to have completed every prerequisite. So I need to go through here and find, no, not find that. From the skill here, get the prerequisites. Okay, which is our array that we made earlier. And I need to do a for each loop on this one because I'm going to check for each one of them. And I'm going to check if each one exists in our skill ranks. Yeah, I need to have all of them to be able to do it. So in the skill ranks here, I'm going to go in like so and do find and plug that in there. Now this is going to return a Boolean, as we mentioned before. It's going to find whether or not we have the function already in it. Again, we could also change it to query skill if we want to make sure we're using our stuff. Makes it a bit cleaner, a bit easier to read. Query skill, we get the value and the rank. Now, what we can actually do is do a collapsible function. So we can make it so that when it does find one, we can just end it right here. There's no need to check if it has the siblings or whatever. If it doesn't have the prerequisites, then it can't be added, no matter what. We'd have to check anything else. So it's when we can do an early return node to break out of our function. So we'll put a branch in, plug this in here, loop body, and because it's a prerequisites, if this is false, that means I don't have it. Therefore, I can return out. Okay, and because we're asking ourselves a question, can learn skill, I'm going to return a Boolean success or return. I'll just do return like that, and this will be left as false. Okay, now if it manages to get through all of them in query skill as true, it'll never call this. Therefore, it should complete and get down here. So now I can check their siblings. So I can go into skill ranks, not skill ranks again. Do on a skill here, siblings, and this is almost like the opposite of the previous one. So we get siblings, do a for each loop, and plug that in. And I'm doing the exact opposite. I'm finding, do I have it? And if I do have any of it, then again, I want to break out early with a return node. So the function collapses on itself. It ends abruptly, ends early. But if this is false every single time, and I don't have any of these siblings, that means on completed, I can learn this skill. So I'm going to put return node at the bottom, like that. So collapsible functions are a great way to say, like, do all these checks, and if you get through it all, this gauntlet of checks, yes. If you don't, then no good. So there it is. And because we're not changing anything, I'll make it a pure function. So all this complex stuff is tucked away in a nice, handy little node in our learn skill. So when I want to prepare can I learn the skill, I need to say can learn skill, skill to learn, and put that in here. Okay. And again, make life a little bit easier and tidier. We can just tidy up and say, switch all these out for the node version of the parameter. And this is the start of our skill tree system. Okay, and that's the kind of thinking that goes into it. And as you saw, we started with 4, and I've added some extra ones. And I say the extra ones are more for my benefit, to make my life easier as a developer. Now, I could have just put these straight in there and without making them into functions. So what's the benefit of making things functions? Well, if they're functions, that means other things can use these too. So I'm thinking ahead now to my UI. My UI, I'm going to show whether a skill is available to the player to click on and upgrade. Well, I can go for every single skill in the game, and I can call can upgrade skill. If it's true, I can put a little glowing border around it, for example, and say, hey, we can make it upgradable. Same goes with can learn skill. I can make it go from grayscale to coloured if can learn skill comes back true. So by separating these things out, I've got functionality I know I'm going to need later on for other things. Now, it may be the case that when you're first doing this on your own, you may not realise that. So how do you know when to do this? Sadly, it's just practice. When you come to do this a lot, you'll start thinking ahead and thinking, what would be actually useful to me later on? And what you can do is, if you want to do it the long way, you do it the long way. And if you notice that you're repeating code often, like you saw me doing this often, you found me just dragging out skill ranks and doing find all the time. Rather than doing 2 nodes, I can just now do just 1 node and it'll give me the exact same response. Yeah, plus any extra stuff I want to put in it. Okay, so it can be quite useful to break things down like that. But practice will come with it, and as you are practicing, you will start thinking ahead to things like UI, okay, like other systems in the game that might interact with it, and think about like, okay, what could something else use this? If it can, make it a function, make it a variable, make it something that something else can access. Okay. So that is the gist of how we can learn Unreal Engine. Now, as I mentioned earlier, someone asked, like, in the chat, I can't remember who it was, though. I was asking, like, how do you know what nodes and variables there are that you can use? So I'll show you. In this menu, this is a context-sensitive menu. So if I just right-click anywhere in this blueprint graph, it's going to show me all the functions and all the variables that can be accessed from the skill tree system directly. So without having to go through different references, different reference chains, these are the stuff I can access right here, right now from the skill tree system. And there's quite a lot. Yeah, there's quite a lot, because a skill tree, an active component, is part of the world. So therefore you have access to all the world stuff too. But in here, I don't have access to things to the character movement component. Yeah, I don't have access to that stuff because it doesn't belong here. Yeah. But if I turn off context sensitive, this now shows every function and every variable in the engine. Okay. So let's say I don't know what I'm looking for, and I'm going through, okay, I need to be able to change the gravity on my character. Okay, so I'm going to search for the word gravity. Now, I want to find all the things related to gravity. My next step is to look at the category that each function is in. Okay, so this is the first one that's highlighted, set gravity. You may think straight off the bat by the name of the function, that's our one. But if you look, it's in the clothing simulation section. Therefore, it can't be. We're not related to clothing. We're related to characters. So let's have a look what else we've got. We've got get gravity Z. Well, I don't want to. I want to change the gravity. So that's not what I want. I'm going to do a set or something like that. So I'm looking up and looking for various things that are related to the character and setting and changing. So here I can see set gravity scale. And it's part of the character movement component. Sounds pretty good. My last step is I would hover over it and read what it says if it gives me a tooltip. Yeah, and I'll go, yep, that's what I want. I click on that, and there we go. Now, the problem that you have with this is that this won't work on its own. Yeah, if I plug this in, like here, I get an error. Okay, the error is because the target is incorrect. Because I had to turn off the context sensitivity on that menu, it's giving me this thing regardless. Okay, now if I hover over target, you can see what kind of reference it needs. It needs a character movement component object reference. It needs a reference to a component in the world as a character movement component. Well, how do I get that? So what you can actually do, if you don't know any way of getting to that, is work your way backwards. So if I drag from a target here and turn on context sensitive, I'm now going to get nodes that I can use to get into here. Okay, so I can do get character movement. Oh, get character movement. Turn it on, sorry. So if I turn it on, you'll see there's nothing related to it, yeah? So again, I'll turn it off. Get character movement. Ah, there we go. Get character movement. That's what I want. But same problem. It wasn't in the context sensitive menu. So therefore, hover my mouse over target, character object reference. Okay, so I need to know which character I want to change gravity for. Makes sense. So which character I want to do? I want to do it to the player character. So I'm going to drag from here, turn on context sensitive again, and do get player or type in player character. I've got get player character. And now this will work because the chain is complete. I've worked my way back to find how I get to gravity scale. And that is an easy way of working out which way to go. But let's say you don't know about the get player character node. How the hell do you know what you're looking for? Search for keywords. Yeah. Like it told me I needed a character. Well, I needed a player. So I'm going to drag from here and search for the keyword player. And turn on context sensitive. Always do that first. Type in player and bam, there you go. I've got the one I want. Get player character. I want to read the tooltip. Yep, it's telling me exactly what I want. That's the one I want. So just type in keywords if you want to change things, yeah? And again, if you don't know where this thing belongs to, just turn off context sensitive. So let's say I want to do like recording audio. Okay, so I can type in record. Oh. And I can do various things in there. I can search for recording. Do we have record audio? So I'm looking for audio section. And if I really want to help myself, I can type in audio. But there you go. Audio's right at the top. If you haven't realised, it's in alphabetical order. So audio's at the top here. And we've got finish recording, pause video, start recording output. Nice. That's what I want. Let's click on that. So this is, if I hover over it, targets audio mixer blueprint library. So it's not going to really work in this because this is not a blueprint mixer library. So I can work my way back to work out how to get to that, and I can work out what would actually use this for. So yeah, that is how we do that. So that is what we're doing there. Okay, and that is how we can find out nodes and variables that we're looking for. A couple of other little tips with the menu options down here. So let's say do get player character. Okay. Actually, let's do if I type in skill, for example, as a rule of thumb, variables of the thing that you're on will be at the bottom. Okay, so if you scroll right down, they'll be the ones at the bottom. As you can see, it's also going to be these ones because I got this turned off, and these belong to the skill data asset. Okay, so it's highlighted in this area, but the ones I want for this system are going to be at the bottom. Okay, because it's in the variables default section. So anything that you're right clicking on, it's going to return you always at the bottom there. So it's quite quick. If you want to get a certain variable or component, just go right to the bottom, you'll find it there. So that helps you out. So that is how you can learn Unreal Engine better, faster, and actually not having to rely on tutorials made by myself or anyone else forever. You can get by without them. And you'll be able to do things like what I'm doing, where I'm making things up as I go and figuring it out as I go. Yeah, that's the way of a programmer. We don't know everything off by heart. We know how to solve problems. And that is the goal of a programmer, is to solve problems. People often ask us to, can we check to see, like they'll ask me, like, how do you know everything that's in there? Like, we don't. Yeah, we have to, like, figure it out. Yeah, like, I don't know everything. Neither do Epic people. Like, they don't know everything. Yeah, I've helped out quite a lot of Epic people. And because I knew something they didn't know. And likewise, they taught me stuff that I didn't know. And it's just a matter of practicing these things out until you learn some more little tricks. The stuff I know now dwarfs what I learned and you talked about 5 years ago when I started the channel. Yeah, and that's the nature of it. And that's why we redid the inventory system series. Yeah, that's why we redid the quest system series, because I've learned a lot more. I've figured out ways to make it better. I figured out ways to make it more fun. And that's because I experimented with it and made it over and over and over again in different ways. Much like you, the same way too. Okay. Now, skill tree system stuff we can probably do as a whole series, because obviously we haven't touched anything about AI, UI, or anything like that. So we'll put that in probably later on, a big series of that. But look out for that in the future, hopefully. So that's how we can learn anything really, and some little tips there about learning Unreal. And for those doing C++, it's exactly the same. Okay, so you'll find that your header file is basically this section over here. So you're just describing the functions, what they are, what they take, what they give out, what they like return, the variables and what they are. It's all that, and defining things over here. That all goes onto the header file. The source file is the stuff in here. So on learn skill, we can now create different things in here. A branch is an if statement, and true or false is else otherwise. And the rest is just like, these are variables, so we're just going to grab the variable skill to learn from the parameter. Yeah, it's the same concept. Okay, so translating this to C++ isn't too difficult. So those who are learning that way, learning or going through learning C++ is exactly the same process. Okay, break things down into individual parts, and if you don't know what the hell they do, throw some large numbers in there. You'll see me do this a couple of times in live stream. When I don't know what a thing does, I'll just throw a large number in there and see what happens. It's something because when it's a large number, it makes it more obvious. Is less reliant on subtle changes. Especially when you're doing things with physics, just chuck a large number in, see what happens. Does it like go nuts? Who knows? Experiment with it, play with it, and build your understanding of it. So let's take some questions people have about learning Unreal Engine. So put your questions into chat about how to learn Unreal Engine. I'll try to catch a couple of things in here as we were going, so I'll answer a couple that I've spotted here. Casting. Martin was asking about casting. So I've done a whole video about casting, explained it a bit better. But as a quick example of what casting does, casting, a point of casting. So let's say, for example, I've done a cast a third-person character. Now, get player character here is a function built into Unreal already that returns a character object reference. However, I have a variable or function or component on my particular third-person character that doesn't exist on a generic character object reference. So casting is how we cast a reference, a parent reference, down to its child reference, because we can't reference things that it doesn't know about. So if we cast this to the third-person character, I can now change that. I'm basically transforming this reference here into its child version, and that now allows me to access variables and functions that are available on that child version. Okay, people I see often use casting as a check to see whether something is equal to something else. That's not really quite a good way of doing it, because casting is relatively more expensive than a simple check. Because with casting, it has to try and change the asset type over to a different address type. Because when we store pointers and references in code, for example, we have to store what type it is as well. We can't just say it's a pointer. We have to say it's a pointer to a particular type of reference. And so casting is useful if we're making generic functions like this to be more specific with them later on. Okay, so that's what casting is. Casting in C++, you can cast in C++, yeah. With C++, if you want to know how to do any of the functions, and especially the exact parameters you want to use the documentation. So go into UEFI documentation, type in cast, and you'll see the C++ bit of the casting, and you can see it there. Secondly, with this C++ stuff, if you really are struggling to see how things are made, download the source code of the engine and just take a look in it and see what they've done. You can see some examples of how stuff is made. Lottie, if you, I guess you're talking about me, if you really get stuck on something, where do you go? Are there forums you recommend or people you can reach out to? So, if I get stuck, I just keep experimenting. That's what I do. I'll experiment. I may Google a couple of things and like saying like, hey, has anyone else messed around with this tool before? And just do that. That's literally what I do. I don't follow anyone in particular. I don't go on the forums in particular. I maybe check out documentation if there is there any, but it's not that great. A lot of the documentation. A lot of it is just telling you the header file stuff, which is, plain. So a lot of it is just, I learn a lot by just experimenting. Okay, and if I really, really do get stuck, I'll just say, I'm moving on. But it's very rare I get stuck. It's because, like, by the time I bash my head against it for a while, I would have figured it out by then. So, yeah. But, yeah, check out. There are communities available, obviously. Ask around. Because other people would have had other issues. Like, look at the Unreal Slackers. Look at my Discord. The Unreal Forum's a great wealth of resources for this. But, yeah, just Google. Yeah. Martin's asking, one thing that discourages me from programming by figuring out stuff on my own is experienced programmers people screaming at me because I'm learning it the wrong way. You get that for everything. I always say, if it works, it works. Yeah. If it works poorly, then it works poorly. Yeah. Then you can, that's another problem you experiment and play with and find a solution to. You'll often find that you're too busy worrying about the wrong thing. If you think that Diablo 4's code is going to be pristine and well commented and no bugs in it whatsoever and looking nice and tidy and clean and efficient, then you're kidding yourself, yeah? The projects I've worked on, obviously I didn't work in Diablo 4, but the projects I've worked on with different companies, a lot of the time you're dealing with code that is just a mess. It's hard to navigate around. You're figuring it out. So yeah, don't worry about it. You're used to seeing crappy code. It's like when you get a new book. You spend a lot of time taking your time on the first page. Right, this one I'll keep nice and tidy, nice and neat, organized. But by the time you get to the last one, you're doodling away like crazy, and it's like got coffee spills on it. It's just a mess. it's the same with code. Yeah, the first time you start building a system like this, like a skill tree system, it's nice and tidy. Everything's organized. I'm commenting things. I'm describing things and detailing things. But by the time I get to the end of it, I'm like, just get this finished. Blah. So don't worry about what people are telling you, and if they are giving you constructive criticism, then take on board that constructive criticism. But don't worry about just criticism. If people say like you're crap at what you do, blah blah blah, if it works, it works. Yeah, like who cares how you got there? If it works, it works. Simple as that. How often do you stream? I'm interested in watching, but can't stay on at the moment. So I stream every Saturday. At the same time every Saturday, and every Wednesday as well. Wednesday we do more of a question time where people can ask their questions, and Saturday's streams are a bit more themed. So next week, for example, we're going back and looking at my current game I'm developing called Mimic, and looking at the progress that's done there. Okay. Do you think taking classes on Unreal Blueprint is the way to learn from point zero, or working on a simple project and learn with trial and error? It depends on the person. So I'm more of a trial and error kind of person. I don't like following courses and things like that, because again, if you're following a course, it doesn't give you room to experiment because you're just following steps. So much like how when I designed and created the Making Your First Game in Unreal Engine 4 course, that's on YouTube and Skillshare and other things. At the end of that course, I put in some challenges for people like, hey, here are some 3 things to try and make on your own, taking what you've learned from this course. I'm not going to tell you how to do it. I want to see if you can figure it out on your own. And I think people really like that sort of structure, and that's what I'll be doing a lot more of when I go into making more courses, like actual courses, not tutorial series, but courses. Is putting in these little experimentation sections where people can like, okay, you've made this, make another one, but make it different, make it in some sort of way. That experimentation really does help. So I like courses that allow me to do that and stretch a little bit. I don't like ones which prescribe me how I'm making things. So, like, follow this exactly to the T to learn and to create Pac-Man. Like, great. I've learned how to make Pac-Man, but I've learned how to make nothing else. So that's where if I'm going to do something like that, I'll be following along, but I'll be stopping at each one, understanding what it does, breaking it, experimenting as I go. But a good course would tell you to explore the idea itself. I used to be a teacher in the classroom. An exploration of knowledge is a core tenet of a learning cycle. Yeah, we identify what we're going to learn today, we discover what we're going to learn, and we give a chance to explore what you're learning. Yeah, and then conclude from that learning. It's a common learning cycle that we use as a teacher. So same concept I would be applying to courses there. Seth, BP okay for replicated game, or should I learn C++? Yeah, you can do it in Blueprint. That's fine. Blueprint versus C++. Blueprint is going to be quicker for iteration purposes, but honestly, both best use case is to use both at the same time. Use C++ to optimize things that need optimization, but honestly, the speed between Blueprint and C++ is negligible at the moment. Like, you're not going to really make a big difference by making it all in C++. The thing you do have access to in C++ is everything. You have access to absolutely everything. Whereas Blueprint, you're only available to things that are exposed to Blueprint in the reflector system. So if it's not exposed, you can't have access to it. Yeah. So yeah, do be aware of that. That's the big thing there. But I say most professional AAA games, it'll be a combination of both. Blueprint is a lot quicker to prototype and implement. So you'll find that a lot of companies will like build a lot of their systems in Blueprint first and then go back and optimize them in C++ later. Like this skill tree system, I could make all this and then I go, right, I'm now going to convert it all to C++, and I've now got a C++ system. But a lot of people like learning Blueprint, so I'll leave it as Blueprint. But yeah, honestly, it's not much different anymore. A lot of the comments you hear about people saying like Blueprint's so much slower than C++, that's old. That's historical data. Like, it's not that slow really. It's still super fast. Yeah, it's just with C++ you have access to a lot more memory management, so you can be super optimized about it, and also you can change a lot about how the engine works too. Yeah. Suresh, hello, I'm new to Unreal. Sorry if this is already asked. What's the best way to learn and start? Go back to the beginning of the live stream. Start from here, because that was the whole point of the live stream. Um, Jordan, we kind of see a difference for our custom gesture recognition for hand tracking with Blueprint versus C++ implementation of the method. Yes, you will in that case, because you are dealing with things on the tick more so than anything. When it's event driven, you'll find yourself a little bit, not much difference when you're dealing with the tick and doing like runtime stuff and dealing with a lot of the directly with the hardware, like cameras and things like that. Yeah, C++ can give you a much better connection to that stuff. But generically, like for making games, there's no difference really. Yeah, it's really not worth the fuss. A couple more questions, but then we're gonna go. Do you plan on more courses? Yes. So over the summer, I was thinking of doing another making your first game, but in Unreal Engine 5, improving on the core structure of it, as I say, by implementing more experimentation earlier on rather than leaving it to our last video. So it'd be like each end of each chapter you go like, right, now try this sort of thing. So yes, there will be a course coming in the summer. Well, it'll be being developed in the summer. God knows when it'll be actually out. But that's what we're going to do. Yeah. Do you get tired of repeating yourself while streaming? I've recently learned that about myself, that I get tired of it quickly. I say I used to be a teacher, so repeating what you said was very common. So it's not a problem. I'm used to it. Is it C++? The course won't be C++, no. Probably another course we'll do in C++. Going through lots of questions here now. Mohammed, when someone work with a company that uses its own engine, will it be different from Unreal? Yes. So engines do differ, but once you've learned one, you can learn them all. It's not doesn't take that too long to learn. So like for example, if you learn Unreal pretty well, you could probably pick up Unity quite quickly and got up quite quickly. Nowadays, engines like consoles are very similar to each other. It's just different under the hood stuff and different interfaces and tools and systems available to you. So yeah, there's a little learning curve, but once you've learned one, you learn them all. It's much like programming. Like if you've learned C#, yeah, it makes learning C++ and Java and all these other ones a lot easier because you know the core fundamentals of programming and computer science stuff. Yeah. Jake Jams, any experience with rhythm games? Unreal Audio ready for that yet, or do we still need to learn F model WYs? You still ideally need WYs or something like that, because you need a proper breakdown of audio tracks. You can do something akin to it, which I've done a live stream of like a few months ago, like February, when I made a Let's Create of Hi-Fi Rush. I showed it a bit in there, but it's not exactly what you want for a rhythm game, but it's enough to get by. But that's going to be all for today, unfortunately. We've run out of time. Hopefully, everyone's found this live stream very useful. I want to say massive thank you to everyone who has turned up. We have got more live streams coming every week on every Saturday and Wednesday, so do check them out. And obviously, new video content every single week as well. We also got a Games Jam coming up very, very soon with a cash prize to the winner of that Games Jam. That's starting in a few weeks' time. Early August, I think it is. So do sign up over on itch.io. I'll be sharing more links to that in the due time. So do keep an eye on it, check it out, and sign up. It could be lots of fun. And I want to say again, a massive thank you to all my Patreon members. So this live stream is recorded for Patreon members, and you'll get it straight after the show. Everyone else will have this released later, 2 weeks later, over there. If you want to support the channel, Patreon is a great place to do it. From $1 a month, you get access to all the video content. That includes Luke's animation stuff as well, and early before anyone else. And I can't say thank you enough to everyone who is supporting the channel over on Patreon. So once again, thank you for joining me live tonight. It's been a pleasure talking to every single one of you. Sorry if I couldn't answer all your questions, but we do have question time again on Wednesday, where you can ask all your questions again, and we can answer more questions for everyone. Thank you again so much. Take care. Good night, and I'll see you next time. Bye, everyone.